Okay, hello, welcome. My name is Michael King. I applied for a position and was given a project, and this is what I came up with. So we're going to navigate to the GitHub page where I have named it ML Security PJ. All right, so this is a security findings tracker I built on top of MapLarge's starter project. Since this role is specifically Principal Security Engineer, I use the assignment as a chance to showcase full secure SDLC loop thread modeling, secure authentication and authorization, and SAST, DAST, secret scanning, dependency scanning, wired into CI. So not just a CRUD app. I'll walk through the front end first, then the back end, showing both what it does and why I built it the way that I did. And if you look through everything, I've tried to include as much as I could, as well as a study guide for navigating the usage and why and how for the app itself. Okay, and then I'm also going to include a little bit of my assumptions for you guys, what I think you're going to go over, and I'm going to include that into this as well. But if you go through here, you'll find everything. It is in working order. Okay, so we'll start with the front end. We'll go through the app now. Let's take a look and let's go through it. Okay, a little bit of more preface here. So if I come straight into localhost 7146, we'll notice that it does not work. Okay, so we have to navigate to, in my case, downloads, secure findings tracker, test project, and then we'll launch a terminal from inside of that area. Once inside of that area, nothing to it, just going to launch all three little commands: npm install, npm build, and .NET run. Okay, that should fire off pretty fast, and it's done. We will come back in here and we will go back to the browser, hit enter one time, and we should see that it is now working. And with that, we can take a look at some of the features. We have a light and dark mode, so we can set it from light to dark. You know, don't want to strain your eyes. Can do just a little bit of that. And we are going to log in as an analyst. You'll see I put the password here at the bottom, so no need to run that down. Make sure there's no space in there, otherwise you get something that doesn't work. And boom, we're in. Okay, so no default open access. Everything behind /API requires auth. So if you look here, the role badge and the banner underneath tells you exactly what the session can and can't do before touching anything. So that's deliberate. That's not just decoration. Okay, so we're going to look at the dashboard a little bit here. You'll see we have a couple of things. You'll notice this dashboard. This is like an independent authorization back-end endpoint. So not the same data redecorated. And this owner column, right, is surfacing an access control visually. So this other side says other analysts, and this one says you, lets you know who the owner is. So these are live fields. So if you try to edit something that you don't own, these fields are grayed out. Save as disabled. I want to be precise about what this is. It's a UI convenience, not a security boundary. If I open DevTools right now and remove the disable attribute, the server would still reject it with the 403. The actual check lives in a server-side authentication handler. I'll show that handler in the back end half. So now that we've taken a look at a little bit of this, you can see I'm going to log in as admin and show you where the difference lies. So we can see that it's completely different. So admin is red, and if you notice up here, analyst is blue. As an analyst is if I add something like arcane door, Cisco 0 day. So I just added a finding, a arcane door. You can see where missing rate limit is still grayed out because that's other analysts. We can't control that. We can see where I just put some stuff in. You can see the other stuff I put in. And then we also cannot export. As an analyst, we don't have the ability to export. You can see that when I try, scroll up, I get a export failed. You don't have permission to do that. I'll come over to admin and we'll look at this again. Let's just do a quick little refresh. Let's come back in as admin and yep, there we go. So we can now see that that arcane door is there and we can do an export. Let's export that, see what happens. Okay, cool. So we get a downloads in our download folder. We can open that up and we can see that yes, indeed, it is an actual finding, title, severity, status, score, assignment, team. So all of the information that you might need to pass on to other, other teams, other areas, whatever comes after that. So with that, let's look at some of the code if we can. Let's go back to the downloads, security, test folder, and let's dive into the www root folder, src. You'll notice we have three things in there: API, app, and types. Let's look at types for a second here. And of course, we're going to open that with Visual Studio Code because that's what we're working in. And we're going to look at a couple of things. So this mirrors the C# response shapes by hand. Two things worth noting: severity, okay, is a string. It's a string union, low, medium, high, critical, not a plain string. So the compiler rejects a typo or an invalid value before the app ever runs. So I documented a real limitation here in the comment. A larger service would generate this file from an open API spec so the two sides can never silently drift. Naming that gap just felt more honest than pretending it's solved. So that's just something I wanted to show there. And it's pretty, it's pretty self-explanatory. I use AI in some of this as well, just to keep some of the syntax in the right spacing, in the right area. And then I just put a bunch of notes in there for myself, just so I remember. And I had AI help with that as well. Keep all of my thoughts compiled, make sure I'm not veering off track as I work through this project. Let's dive into API TS. Let's take a look at that one. If I can. Okay, so with this one, so this is every network call the app makes in one place. The access token lives in a module level JavaScript variable, not local storage. Okay, so local storage is readable by any script on the page. So if this app ever had a hard XSS bug, a token sitting there is handed straight off to an attacker, right? So in memory means it disappears on refresh. So a real UX trade-off, but it can't be scraped by, reading storage after the fact. So with that, we just look at some of the findings. All right. So this is just some of the stuff we thought about. We worked through it. And of course, I had AI help with this as well. Just keep some of the logic linear, make it make sense, and then I'll show you where this is working, this 401, 403, and how it stops some things from, it's a rate limit built in. So this function is also the fix for a bug I found and wanted to be upfront about. The first version of export used a plain link. A plain browser navigation has no way to carry a bearer token, so only fetch calls do. So, which only run from this file. So I found that reasoning through the auth model confirmed the root calls with curl, no auth header, 401. With it, 200. So then fixed it, do an authentication fetch and trigger a blob download instead. Okay, so crazy workaround, but it was nice, it worked. Let's take a look at some other code. Let's look at the app TS as well. Okay, so quite a bit here. So every place this file touches the DOM, it uses .text content, never .enter HTML with interpopulated data. That's the actual XSS prevention here. The content security policy is the second layer, not the first layer. Okay, so if you look at the status banner, okay, for example, if you look at, so if you look at the status banner code right here, right, you'll look at this, some of this. I also replaced every alert call with a persistent status banner alert. So it gets silently suppressed by some other browser and extensions and gives no record of what happened. This fires for every outcome, success or failure. Nothing fails silently. That fix came directly from a real bug report during testing. Okay, so we're going to go back and we're going to take a look at another file. The tsconfig.json file. Yeah, let's take a look at that one. So here, string mode, no implicit any, right? Okay, so we'll take a look at this and we'll look at no implicit any true. Okay, so this is TypeScript's equivalent of SAST, a whole class of null reference and implicit any bugs get caught at compile time and CI fails the build on any type error, same as the C side, C# side. So okay, so let's come back over and let's actually use the search filter. Let's see what happens. Okay, so you're right, it works. Okay. So the filter bar hits a real server-side query parameter, not a client-side array filter. So it scales the same way against a real database later. So creating a finding gives immediate banner feedback, and export now works using the authenticated fetch I just showed. Okay. Okay, so to tie this back into the role, the job description asks for hands-on secure coding across TypeScript, specifically alongside .NET and Python. Everything here, the token storage decision, the XSS, safe DOM handling, strict compiler settings. It's the same secure by design thinking as the backend, just compiled to a different language. A language's specific risk. So, okay, let's keep looking at a little bit more code. Let's go back here again, and this time let's open up program.cs. Okay, so everything gets wired here in a specific order that matters. Exception handling first, then security headers, then rate limiting, then auth, and then authorization, then routes, then middleware. Only protects what runs after it, right? So we could take a look at all that. So okay, so I just want to hone in on something specific for a moment. Right here, add bearer token defaults dot authorization schemes. Okay, so authentication uses ASP.NET Core built-in bearer token schema, so not a JWT library. So hand-rolled JWT parsing is a known way to introduce algorithm confusion or signature bugs. So rather than pull in a crypto adjacent dependency to check a box, I use what the framework already ships securely. Same job, smaller trusted surface. Okay, so deny by default rate limiting, 100 requests a minute globally, but only 5 a minute specifically on login. Since the highest value targets for a brute force attack, we're going to do something now. I'll give you another live little demo. We'll come back to the projects folder. We'll kick off another terminal, right? So we're in the right folder. And here I can just expand. I have another handy dandy little snippet for myself here. And we'll kick that off. See 401, just hit up, do that again, 401, up, again, 401, up, 401, 401, 429. So you can see where 401, 401, 401, then it flips to 429. So that's the limiter kicking in after 5 failed attempts inside a minute, right? Okay, so that shows you that portion working. Okay, we're running fast on time. We're going over, so we're just going to try to speed this up here. Let's come back and look at, let's just say controllers, auth controllers. Let's open that up. Okay, so we have a lot going on here as well. But so login hash verifies with pbkdf2 and returns the identical error whether that username doesn't exist or the password's wrong. That's a deliberate defense against user enumeratization, right? So if those two cases return different messages, an attacker could build a valid username list before ever guessing a password. So this right here is built to help stop that, right? So let's look at something else since we bring that up. Instead of controllers, let's look at passwords. So instead of controllers, we'll come down here to security. Inside of security, we have password hasher CS. Okay, so boom, right there, you can see it immediately. PBKDF2-HMAC a SHA 256, so that's 600,000 iterations. That's OSASP's current published minimum, not a number I picked arbitrarily. So a random salt per user and a constant time comparison on verify. So an attacker timing the response can't interfere with how much of the hash matched bytes by bytes. Okay, so this is more of the security framework, kind of going inside and the mindset behind it. Just wanted to make sure I showcase some more of that. And we can even take a look at, let's look at resource authorization CS. Okay, let's open that up a little bit here. Okay, all right, so let's look at this. Okay, so this is the file behind the disable save button from the front end half. So role-based access can answer what kind of user this is. It can't answer, does this specific user, specific analyst own this specific finding? Because that depends on the resource instance, not just the role. So this is a separate resource-based authentication handler. Admin always succeeds, otherwise the caller's ID has to match the finding's owner. And there's no explicit failure branch because ASP.NET's core authorization is denied by default. If success is never called, the request is rejected automatically. So that's what you're looking at when we look at this right here specifically. And we'll take a look at just a little bit more code. And so we'll take a look here. We'll come back. We'll go to test. We'll go to owner admin handler test. We'll open that up and we'll take a look here. Okay, so, and here's the test suite providing that logic. So 4 cases. Admin can edit anything and owner can edit their own. A non-owner gets denied and a user with no identity claims at all gets denied rather than silently matching. So that third case is that one that would catch a real regression of the exact vulnerability this handler exists to prevent. So it's a lot, and I used AI to help me build the fundamentals behind this too, because I'm not really good with owner and identity related things, but we utilize this quite a bit in Cisco ICE. So I do understand how this is done. So I kind of just pieced it together and added it to the .NET or ASP.NET framework because it's a little bit different than what I'm used to. And we'll have a little bit more looking at the code. We're almost done here. So I just want to go back and we'll look at middleware. Okay, so here's the middleware. And so applied globally once to the whole pipeline rather than per endpoint. Content security policy default denies same origin. X frame options, stopping, click hijacking, no stiffing, stopping, meme type attacks, whatever. Structural, not something a new endpoint could forget to add. Okay, so that's why we apply that in that way. Okay, I opened up another file here. So worth a specific call out. Let's just talk about this for a second. So the Excel and Sheets treat a cell starting with these formulas, these plus, equals, minus, or at, okay, as a formula. And unescaped export could execute attacker simplified logic. So we're trying to mitigate the footprint at which these attackers can kind of get in, right? So whoever opens the file. So I verified this directly. Make sure it's a finding with the team name. So say like equals 2 plus 2 exports as comma equals 2 plus 2. So the actual CSV neutralized. This one I really had to get help with a lot too, because I wanted the export to be correct. Okay, I opened up another file here. So this is the source generated logging via login message, not plain logger.log warning calls. This is what the SDK owner analyzer recommends, since it avoids allocating a box object array on every call. A filtered out call log level would otherwise throw away. So I fixed this rather than suppress the warning, specifically so CI's warnings as errors gate stays honest instead of full quiet exceptions. Okay, and I could go over maybe why that's needed, but I think it kind of makes sense a little bit. It's just logging and the messages that you're giving. You want to mitigate that and make them as true as possible. So, all right, moving right into the test project.cs and the GitHub, we will look at two things. So, of course, we need the .yaml to get the GitHub working with all of the instructions for what everything does, what you're expecting, and how you need it to work. So you set all of that out. I like GitHub. I use that one quite a bit. So the analyst mode equals all. So turn on the SDK's full built-in Roslyn tool set, SAST, so no external tool required. And the CI pipeline runs that built with warnings as errors, plus git links for secret scanning, .NET list package vulnerables, and npm audit for dependency scanning, and an OS ZAP baseline scan against a live instance for DAST on every push. That's the direct answer to own and improve security testing across the SDLC, right? So you're given everything because you need to be able to secure it. So lastly, one deliberate trade-off, naming worth mentioning. Data is stored in memory, not in a real database. That removes SQL injection as an attack surface entirely for this evaluation, documented as a concise choice in the threat model, not an oversight. What did I find fun or most challenging? Well, the most interesting call was probably the ABAC layer. It would have been faster to let an analyst edit any finding, but that's not how a real findings tracker should behave. Building it as a reusable authorization handler instead of a inline check means the same pattern works everywhere else. Ownership matters later, and it's independently testable, which the 4 tests I showed prove. Sorry this ran very long. I know you asked for 5 minutes. I'm almost at 30. But I'm going to upload this video to this as well and send this all to you guys today. I hope you enjoyed it. I hope it is something that showcases a little bit. And I'm sorry if something is not very good. I'm very rusty. I use quite a bit of other languages, and I kind of utilize some other stuff than this on a daily basis. I look forward to speaking to you all about the project, everything that I used, what I didn't use. I'll just showcase really fast what I'm usually doing. I usually I have a lot of Docker, Kubernetes, Rancher, a lot of self-hosted apps, and I run them. I create a lot of this from scratch, my own dashboards, my own apps, my own websites, all of that good stuff. Or take open source software and improve upon it and add it to my own schema. You can also find that in my GitHub as well, labeled PSOS, Personal Sovereign Operating System, where I have taken offline everything and run it here locally. Just a small sample of that is one NAS running by itself as a test environment. Here is just 56 containers running a bunch of microservices that you can see here. So normally what I would do is I would come over to something like Cloudflare. I would have taken that app that I just showed you guys and I would have made it available online, given it a HTTPS, www, website name, all of that good stuff. And yes, I would have been utilizing it, but you guys didn't ask for all of that, so I just decided to try to keep it all out just in case. I use Claude for scaffolding boilerplate and as a secondary option on security design, but every security relevant claim was independent, verified, and taken on faith. I actually ran the app and exercised the RBAC and ABAC boundaries, the rate limiter, and the CSV injection. Defense with real requests to confirm the status codes 403, 401, 429. So not just asserted in a comment in daily work, it's the same pattern. AI assisted generation with deliberate critical review, especially anywhere touching auth, crypto, or input validation, where a plausible wrong answer is more dangerous than an obvious one. That's it. Thank you all for watching. Sorry for the time. Appreciate your guys' efforts and your time. Thank you. Goodbye.